All right. Yesterday, we learned about Lewis dot structures, how to make them. We're going to start today by practicing. So, I want us to draw NH3. Okay, what is our first step?
Find the total number of valence electrons.
Find the total number of valence electrons. Max, how many does nitrogen have?
Nitrogen has 5.
EJ, how many does hydrogen have?
1.
How many hydrogens do we have?
3.
So we have a total number of electrons of 8. Yep. We have 8 valence electrons. So, in our drawing, we have to have, or show, 8 electrons. Now, between our 4 atoms here, which one is going to be the central atom? Haley, why nitrogen?
Because it can make the most bonds.
It can make the most bonds. Nitrogen is going to be our center, which means our hydrogens are around it. What do I have to do between the nitrogen and these 3 hydrogens? Sydney, put a line. What does that tell me? There's 2 what for each line? There's 2 electrons for each line, which means I've used a total of, I have 2 electrons left. Yeah. In each line?
Yeah.
Just the way it is.
Oh, there's always 2 in each line.
In each line, there's always 2.
So a line means 2.
A line means 2. There is an electron from the hydrogen and an electron from the nitrogen being shared between the 2 of them.
Which means you always have 2 left.
No?
No, you times it by the number.
Yep.
Yeah.
Does that make sense?
Yeah.
Okay. So we've used up 6 of our 8 electrons. We have 2 left over. Where are those 2 going to go? On the top of the N. Why? It's missing 2. And it's also... What? It's also... the more electronegative. Oh my goodness, guys.
What was I here yesterday? Electrostatic.
No.
Electromagnetic.
No.
Electronegative.
Electronegative.
Bro.
Electromagnetic.
Woo! Nitrogen is more electronegative, which means what?
It gets them.
I mean, yeah, but what does that mean about nitrogen compared to hydrogen? It wants more the electrons more than hydrogen does. Okay? Nope.
What? They're sharing it.
They are sharing them.
So it'd be easier to get rid of than it.
Nope.
Because there's 1, 3.
Hydrogen's different because it can only get 2 electrons to complete its valence shell. All right. This is our structure. Is everything at its octet?
Yes.
Yes. So, we are good. We do not have to go on to step 6. Wait, you guys didn't even find out about step 6 yet, have you?
I'm so confused.
Okay. Everyone stop talking. Hydrogen, its octet is at 2 electrons. A full valence shell would be 2 electrons for hydrogen and helium, not 8.
That's only for them.
That's only for those two.
Everything else is still 8.
Correct.
Have we learned this?
Yes.
So did we write down the steps yesterday?
Yes. And I gave the sheet to Haley and Annie, but you can get it after them. Okay. Questions on that? All right. Now you guys didn't go through step 6. Step 6, oops, only happens when all valence electrons are used up and there is an element with an incomplete octet. Okay, so this would happen if, say, for instance, we've used up all of our valence electrons and, say, nitrogen still didn't have its 8 electrons. Okay, we'll go through in a specific example, but this happens when not everything completes its octet, but you don't have any more electrons to give. Does that make sense? Okay. At this step, we take lone pairs of electrons and convert into double bonds. Okay, a single bond is just our single line. Okay, that is 2 electrons being shared. If we have a double bond, how many electrons are being shared? 4. Our example here is carbon dioxide. Now we're going to go through this just like our regular. What is our total number of valence electrons for our 1 carbon and 2 oxygens? How many does carbon have? 4. Oxygen has 6, and there's 2 of them, so we have 12. So our total is 16. Our drawing has to have 16 electrons shown. No more, no less. Okay? Between carbon and oxygen, which one can make more bonds? Carbon can. It only has 4 valence electrons, so it can make 4 more bonds. Okay, oxygen has 6 valence electrons, which means it can only make 2 bonds. Okay, so carbon is our central, which means there's an oxygen on either side of it. What do I have to do with these carbon and oxygens, Charlie? Put a line to each one, which means how many electrons have I used so far? 4. That means I have 12 electrons left. Between carbon and oxygen, which one is more electronegative? Oxygen. Oxygen is farther to the right. So, oxygen is going to receive the electrons first. How many electrons are around each oxygen right now? 2. So how many do each of them need? Well, they need 8, but they need 6 more to get to 8. Okay? So, we start adding electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 0 electrons left over. What's our problem here? Haley. Carbon doesn't have enough electrons around it. It only has 4 electrons around carbon right now. How many does it want? 8. So, we're going to take sets of lone pairs of electrons, and we're going to move them into double bonds between the carbon and the oxygen. Now, how many electrons are around each oxygen still? There are 8 electrons around each oxygen. How many electrons are around the carbon? 8. Yes?
Does it matter if, like, on oxygen, white dots are on the top and side, or do they have to be on the top and bottom?
Doesn't matter. Yeah.
I'm still confused on how to find the center one.
The center one is the one that can make the most bonds. So carbon has 4 valence electrons, correct?
Yeah.
It wants 8. And the only way it can do that is through bonding. So in total, it takes 1 electron per bond for each atom. So carbon wants 4 more electrons, it can make 4 more bonds. Oxygen has 6 electrons and needs 2 more, and so it can only make 2 bonds. Does that make sense?
Yeah, but on the other one, then how is nitrogen the center?
Nitrogen has 5 valence electrons, and so it can make 3 bonds.
Yeah.
Hydrogen has 1 valence electron, and it only needs 1 more.
Okay.
Okay. Any other questions? Okay, notice in this picture, I still have my total 16 valence electrons. Okay, I'm showing 16 electrons right now. We have 8 in terms of dots, and then 8 in terms of bonds. That's still 16. I didn't add any, and I didn't take any away. I just moved where they were. Does that make sense? Okay. We're going to try another one. Silicon disulfide, SiS2. Valence electrons. How many does silicon have?
4.
Sulfur. 6, but there's 2 of them. So in total, 16 valence electrons. Your drawing should have 16 valence electrons in it. What is my, oh yeah, sorry, Emma, what's up?
I have to hear now that
Okay. So right now, we have 1, 2, 3, 4, 5, 6, 7, 8 electrons used. We need 8 more to get to our 16, right? Okay. So, okay. So which one is more electronegative, the sulfur or the silicon? The sulfur's farther, right? So the electronegativity goes up, right? Okay. So sulfur is more electronegative. So those electrons that you have left over.
wait, so would it be
Okay, can I see your pencil real quick? So the electrons we have left over are going to go first on the sulfurs. We have them left over, we can put on the silicon. So we have 4 unique bonds, right? Which means we have 12 left. So that means we're going to add 2 sulfurs first so that they complete their octet. And then if we have any left over, we can go to silicon. We don't now though, because I just added 12. Okay? Since we don't have any left over, then we have to look and see which ones are completed and which ones are not. Sulfur, these 2 are complete. Octets, right? Is silicon? No. So what we're going to have to do is we're going to have to rearrange some of these electrons so that silicon and the sulfurs can have their octets completed. So we're going to take those 2 and put them into bonds with silicon. And now it's silicon. And there's 4 left over on the silicon. Does that make sense? Okay. All right. So, silicon has 4 valence electrons, which means it can make more bonds than sulfur. So silicon is going to be in the middle. Now, we have our sulfurs on the other sides, and we put a dash through them. Okay? How many electrons have I used? 4, which means I have how many left? 12. Which elements are going to get the electrons first? Why the sulfur? You're correct, but why? It's more electronegative than the silicon, okay, which means it wants the electrons more. We're going to help the sulfurs complete their octets first. So now sulfur is complete, but I've used up all of my electrons, right? I have 0 left over. So, is silicon complete? No. So what am I going to have to do? I'm going to have to take some lone pairs from the sulfurs and convert them into bonds. Remember, 2 electrons per bond. So that silicon completes its octet, as well as the sulfurs themselves. And there's my there's my drawing. Does that make sense?
Is this the geometry or?
No, this is the drawing. We are not into geometries yet.
There's geometry and chemistry?
Yeah,
Oh.
but not math geometry. Just shapes.
Oh. It's still bad.
It's still fun. All right. Now, a key thing to keep in mind when you're making these drawings is how many bonds can this element make? Okay? We've already talked about before which one can make more bonds than the other, right? Yay, nay? Someone say no? Oh. So, if we look at our sulfur here, if we look up at this drawing, the one that was incomplete, sulfur normally, or sulfur on its own has how many valence electrons? 6, which means it can make how many bonds to get to 8? 2. So if your drawing has sulfur making only 1 bond, something is probably wrong. Does that make sense? Yeah.
Is a line on that side and a line on that side one bond or 2 bonds?
This is a single bond. This is a single bond.
So,
This is a double bond. This is a double bond.
so if there's double bonds, does that mean there's 4 bonds?
There's 4 bonds in the total molecule, but between these 2 atoms, there's only 2. Does that make sense? Okay. So if an atom of sulfur can make 2 bonds, and your drawing only has it making 1, something is probably wrong. Okay, your drawing is probably not complete. Same with silicon. Silicon can make 4 bonds. Up here in this drawing, it only has 2. So, we need to make silicon have 4 bonds to it. And that would most likely make our drawing correct. Does that make sense? Okay. I'm going to give you guys one that I want you to work on your own. It looks daunting. I promise it's not. CH2O.
So, carbon, 4 bonds, so you get 8 bonds. Okay, so carbon. So remember, everything has to be connected to the central atom. Okay. Follow. Which one can make more bonds? Carbon or oxygen? So carbon. Yep. Absolutely. How are we doing? Almost there.
If it's right there,
So far.
really?
Mhm.
I don't know if you can do that.
We're good. So far, you're perfect. Yep. Almost. Drawing has that. Any other electrons left over, right? So they should have all gone to that one. So,
talk about your you do something.
Alrighty. So, how many total valence electrons do we have? 12. Carbon has 4. Hydrogen has 1, and there's 2 of them, so that's 2. And then oxygen has 6. So in total, that is 12 valence electrons. Okay? So we have 12 valence electrons. Which one of our elements here can make the most bonds? Carbon. Carbon has 4 valence electrons. It can make the most bonds. So carbon is going to be our center, which means all the other elements are around it. Okay? And I also have to draw what in between? Lines. How many electrons have I used up? 6. So I have 6 left over, right? Which element is it going to go on first? Oxygen, because oxygen is farther to the right on the periodic table, meaning it is more electronegative. So we're going to put 1, 2, 3, 4, 5, and 6 to give this oxygen 8. But I've run into a problem, haven't I? What's my problem, Peyton? Carbon doesn't have enough electrons, right? It only has 6 electrons around it, not the 8 that it wants. And how many bonds can oxygen make? 2. Right now it only has 1. So we're going to rearrange some of these lone pairs of electrons to make it have 2 bonds. Yes, Jenna?
Is the hydrogen already?
Yes, hydrogen has a complete valence shell at 2, and it has 2 electrons in the bonds, so you're good. Okay, so we're going to take those 2 electrons, move them down into a double bond, and now we have this. And that is our complete structure. Any questions? Comments? Concerns?
9.
Do we want a preview of tomorrow where we actually learn geometries?
Oh, come on.
We can wait.
No, we learned like Thursday.
No.
So many people are going to be gone tomorrow.
Yeah, and they're going to have this video. Fine, that's it for today.